Okay, thank you. Welcome to this our webinar here from Cloudafactory with a guest host from KeyMaker. I want to go over some housekeeping rules real quick. Uh, as you can see on this slide, we're going to have a Q&A session at the end of this webinar. So please use the function at the bottom of your Zoom application to where it says Q&A next to the chat button. Please put as many questions as you have. We'll try to get to them at the end of the webinar, as many as we have time for. This is for you. So we want to make sure we address those as much as we can. Then there will be polling, 2 polls intermittently during the webinar. These are also important for your feedback, and we can discuss these during the webinar. But when they're launched, they should pop up directly on your Zoom screen. So check to make sure they're not hidden. If you're on an iPad or an iPhone, you may not be able to see these polls. So we apologize in advance for that. That's just a function of Zoom. And then recording, this webinar is being recorded currently, and an on-demand version will be shared to all the registrants in the future. So if somebody at your company or household wasn't able to view it live, you can share it with them certainly there. And if you have to duck out, please do so. We will send the full recording later and you can catch up on that. Now that that's out of the way, I also want to talk about, we are live, right? So we're all working from home. Maria and I are on our best internet connection behavior as we can be. So we apologize if there are any internet connectivity issues. This is the real world. We're going to roll with the punches, if you will, and continue on where we need to. I am Anthony Scalabrino. I am a sales engineer here at Cloudafactory, and I like to explain my position as one of the 10 principles of Cloudafactory, which is one body, many parts. I sit mainly on the pre-sales sales side, solutioning. So I look at the holistic thing. I've seen anything from computer vision, NLP, the subsets of those, and help the client meet their needs in their holistic solution. Whether they're going for metrics such as accuracy, throughput, a combination of everything. That's where I sit on the Cloudafactory team. And then, as you know, there are a lot of moving pieces to this data training pipeline. And as a result, Cloudafactory has many strategic partners to ensure our clients the utmost success. And one of those partners today we have with us is KeyMaker. And today I have Maria Gracer, who is the VP of Partnerships at KeyMaker. Maria, please introduce yourself, tell us who you are and what KeyMaker does.
Hi guys, so I'm Maria. I'm VP Partnerships at the KeyMaker, and KeyMaker partnering with Cloudafactory for data collection. So this is a part that we work with Cloudafactory on. A little bit about myself. So I've been in the IT industry for more than 13 years, working with various companies, everything in AI, in computer vision, and here we are.
Nice. So Maria has some experience. That's why we invited her on to this webinar. It'll be a good, interesting conversation that you guys should be looking forward to. So as I mentioned before, there's a lot that goes into data acquisition, especially in the pipeline via strategic partnerships. And at Cloudafactory, we have also helped clients acquire data ourselves. And we'll get to that later on when we talk about the manual collection process. And that's something, if it doesn't exist, Cloudafactory can help do as well. And a part of the current pipeline annotation, the first step of the process is most often data acquisition. So you have to have something to annotate in the first place. So today we're going to go over what makes the ideal data set. Once you have that data set, are we going to bring that? Are we going to have it ourselves? Or are we going to find that, whether that's open source, or talk about other ways for that? Best practices, let's say we didn't choose to go to open source, best practices for building our data set. Then we're going to talk about some of the things associated with data sets, which is sensitive data. What if you come into sensitive data that you've collected or actually have? And then one thing unknown that might scare a lot of people, what if the data doesn't exist? What if I'm trying to do something new? So we can talk about those in this progress. Again, I'll reemphasize the importance of the Q&A and the polls. Just know that this is here for you guys. So we want to answer as many questions as possible. So I'm going to jump right in, and we're going to talk about what makes the ideal data set. So you can see here, I have some things that I've defined. These certainly aren't all the end all be all. There may be more factors that apply into this. But the first I'm going to start with is variance. right? Let's talk about a good use case that is prevalent, which is autonomous vehicles. And everybody can understand this, at least the premise of it. When I talk about variance, I'm talking about not just collecting cars or sedans, right? We need to collect trucks, we need to collect SUVs, we need to collect crossovers, and not just that, but different makes and models. Maybe you have cabriolet, or maybe you have a coupe versus a long family sedan. Like, all these things matter. And then just that, what about variance in the aspect ratios? You don't just want at stoplights looking at the tail end of a car. You want to have side, corner, turning, different aspect ratios. Occlusions, what if things are hidden? Truncation, hidden by the camera itself. And that kind of gets into the point of the real life as possible, right? We don't want to train our model or gather data sets that are going to train our model in a black box that doesn't exist in the real world. Then we're going to get to quality. So this, we're talking about high things like resolution. Are we going to be able to get pixel level perfect annotations on these images that you're providing if they're very high granular and not very well defined? Or are there obscurities that we don't intend for, maybe smudging or occlusions by other things that aren't real world scenarios? And then we're going to jump into quantity or amount. So in my book, you can never have enough data. Maria and I will talk about tiered gathering, so you don't go too far too fast, but the more data you have, the better that is, generally speaking. And then density. So density of objects in that image. So if you're collecting for cars, you don't just want one vehicle looking at another vehicle the entire time, one car per image or one pedestrian per image. You may need longer or more images of that single objects in the instance, and that may train false implications inside your data set. So I would encourage you to have a density of a lot of different vehicles or a lot of different pedestrians or traffic lights, depending on what you're trying to train on in that data set. Maria, now we're talking about these variables, and I said that we can have more than just listed here. What have you seen that affects the quality of a data set, other than what I've just highlighted here?
Okay, so a couple things I think that are very important in a good data set is that the data set is not biased. So having a bias, it's a very big problem for a data set. So taking your examples about autonomous vehicles. So if you collect let's say videos or images, and they all come from the same region, let's say they all come from New York, which means your model would be trained to work and be relevant only for certain weather, certain road conditions, certain traffic signs, and even certain pedestrian behaviors, right? So it's very important that we minimize the bias and try to make sure that our data set is as less biased as possible. It really depends on what exactly we're trying to do, but it's very important to remember that the first thing, there's always will be a bias. There will be some bias, but try to minimize it. It's very important. Another thing is a good data set has to be organized and easily searchable. So for example, you want to find all the vehicles that are from certain kind or certain road situations, you'll be able to find it. Let's say if you have hundreds of hours of videos, but you have no idea what's happening where, that would be a bit tricky. And of course, the precision of the annotations, the quality of the annotation is very important. We'll talk a little bit later about tiered collection. So I leave them to that.
Awesome, thank you. Yeah, so not only these topics, but bias, not that it could be bad, but it also could be good depending on what your objective is. And then also the organization of the data. It's good that you've collected it, but it needs to be organized in some fashion so you know when to train it. And that could come in effect when we're talking about tiered data. We'll talk about in a moment here. We're going to pop up a poll here in a second. It should pop up on your screen. We're going to talk about the next topic is how do you typically acquire data sets for machine learning models? Using an open source data set, building your own data set, creating with an external vendor, like one of us, or another method that you may have. I know when working with Cloudafactory, we have maybe, I don't have the figures in front of me, I'd say 10% of the time somebody wants us to build and bring a data set with us. It might be more heavy on that, but I've seen a lot of them bring their own data sets into that, and I'm curious to see what the poll results were on this one. Maria, what do you think generally? Yeah, so they either come with the data, so they're going to build it, or bring open source, it looks like. So it's interesting to see the tie, at least to me, between the open source and building your own. Is that what you've seen commonly from your end?
Usually it's build your own. That's what I've seen so far.
Yeah, that's what I thought was going to be the leader on there. Build your own, maybe 70% of the time, but it looks like a lot more people are relying on open data sets maybe to just begin. That's interesting. Let's get into that topic. We've talked about what makes an ideal data set, and we ventured into this with this poll about how we're going to obtain it. So we can talk about open source, building our own, and then maybe a pre-labeled data set, which is kind of its own discussion. So I'll just highlight that, and we'll talk about open source or building our own. So in open source, you can see here just a high level, but it may be generic and not have the quality metrics that we mentioned above with the variance, quality, quantity, things like that. However, it may be readily available, and there may be a lot of data in that. But it also may not fit your specific use case. So you might need to turn to pre-label, which it can be time consuming, but you can deliver exactly what you need if you follow the metrics above and some of the things that Maria and I talked about. And then just touching on pre-labeled data sets, you know, obviously Cloudafactory is a premier labeling service, managed labeling service. So you could get a pre-labeled data that just is really poor, and you're going to have to validate and adjust, which we'll get to a little bit later, a lot of that data. So how good was that algorithm to train that data? Does it apply to the previous metrics above? Does that apply to the data set that was trained on it? If not, then you're probably going to have biases. And or does it meet your in-house quality standards? So probably not. And that is a little bit of the pros and cons. You might spend a lot more time validating and readjusting those labels. So we're going to focus on the open source versus the building your own, since that was the top two categories. Maria, in your standpoint, what is the cost and time comparison when deciding whether to gather open source or just build our own data sets?
In my opinion, open source, it's great if you can find what you are looking for. And the largest, like the biggest problem with open source datasets is that the data just doesn't exist. And if it does exist, there is not enough data. And if there is enough data, the data is not specific. And then, of course, you have the quality of the data set, and the quality, if it's pre-labeled, the quality of the labeling, as you mentioned before. So taking all this into consideration, if you can find something that fits your needs, by all means, go for it. But in most cases, that's not what's happening. And the lack of good quality data and enough good quality data can significantly affect the outputs of the model that you're trying to create.
Awesome.
So,
yeah,
but again, it's for free.
Yeah.
If it works, it works.
Yeah, there are clear trade-offs, right? We can get into the discussion of whether it's good to maybe start off that way, but then you may train your model with open source data, and it may be too generic for what you're trying to accomplish.
Yeah. So like the easiest, like the most common use case is when you're trying to develop a model, you're not sure exactly what data you need. So you don't know exactly how it should look like, how it should be labeled. So then it makes sense to go to open source, try it out. And also you don't need the exact data, you're just like playing around, trying to develop a model. You're not really, it's not like a real life scenario that you needed to work perfectly. So then open source works great. But the moment it has to be specific, the moment it has to be precise, and you need good quality output from the model, then open source is not sufficient in most cases.
Perfect. So quality in, quality out. And if you truly want to be competitive in the marketplace, you should build your own or talk about gathering some data from a company like yours. Let's see. So thinking about that as a company, right? If I'm looking to get started or I'm already established, where do we draw the line when we want to choose between creating our own data set or grabbing what exists on the market? And I know we touched a little bit about that, but there may be some other than open source data sets that exist that you guys can provide. Where do we draw the line between those two options?
So there are some pre-made datasets that are not open source, but they're pre-made. So these datasets can be purchased, but it's not custom made. I would say there are 3 tiers in custom made data. First, it's the open source, which is for free and open to everyone. Second is pre-made datasets. And third, it's actually custom made dataset that is based on the requirements and the specifications of a certain machine learning model. So that would be like the top highest quality and tailor-made solution.
So that tailor-made solution, can that be something that you as KeyMaker and Cloudafactory, once given metrics or certain instructions, we can gather that from either open source or paid for data sets? Is that kind of the approach on that? So
the moment it's tailor-made, so basically we have to collect or create the data set, and then the data set the data has to go through the labeling process, which basically where Cloudafactory comes in.
Perfect. Thank you so much. So let's decide for various reasons that we wanted to build our own data set. The open source didn't work. We got past that stage and we want to be competitive and we want to be clearly defined. We're going to talk about the best practices for building our own data sets. So there are 2 methods, at least main methods. There might be other subsets of these. Automated versus manual collection, right? So when I think automated, I've seen data scraping algorithms or data scraping technologies that are even looking for hedge fund material or looking for certain images on certain things. So it can be text or visual, or manual, where you have your internal team or hire Cloudafactory to do this manual scraping when given some set of metrics. What percentage have you seen that are an automated versus a manual process? And then a follow-on question to that, what are the practices KeyMaker follows when building data sets?
Okay, so automated versus manual. We do have some tools developed, basically our technology for scraping the data, for automating the process of collecting the data. But the most important part of this collection, it's actually the validation that comes after. So what's the manual part? Or the data is collected manually. I would say it's about 60% manual, 40% automated, but the manual always comes at the end to validate the quality of the data.
Okay.
Now,
yeah.
sorry.
Now, process is that, and then when I think of validation terms in Cloudafactory, when we've made labels or see quality, you can have the choice to disregard certain images or to accept. Is that kind of the process you're talking about at a high level?
Yes, it is. It's basically going through all the data and making sure that the collection is precise and there is no irrelevant data in the data set. Now, the most important, I would say, one of the most important parts of creating a data set is collection in tiers. What does it mean? So, for example, you need 100,000 images for training your model. So we would not go and collect 100,000 images right away. We would break it down to tiers, to little chunks. So we would collect 1,000, run this 1,000 images by the model, see how it works, see if it's good, adjust, then collect another 1,000. Do the same process again, run it by the model, see how it works, adjust, and collect again. And usually it takes 3-4 takes to actually realize what data exactly needs to be collected and what works best. In terms of the performance, and it's also time and cost, right? Because you want to get as less data as possible to perform to generate the best results. So
Yeah, so
here I think collection in tiers is very important.
yeah, and that ties into what we talked about previously with biases, right? So you can tell if there's any biases coming in your algorithm.
Exactly.
Data tiers.
Exactly. Last thing that you want is collecting all the data at once and then realizing, that's not exactly works.
Yeah, that's a good point. And we talked about both of us as companies, Cloudafactory and Keymaker, can do a lot of this annotation, data gathering, things on our own. But what industries do you partner with typically? And what existing relationships do you have when working on gathering your own data sets?
Okay, so it's literally almost every industry that requires computer vision. So we partner with agriculture companies for collecting agriculture data sets, basically footage from drones of growing fields or images from a lab of growing plants. Then we have dash cams on the cars collecting videos of cars driving around in various locations, which just goes back to the making sure that we minimize the bias. We even have a retail store that to get into the store, you need to sign a waiver that you know that the data from the store is being collected and used. And we basically film real people doing real life shopping, and this data later can be used for training computer vision models.
That's awesome. That's unique. And that I could see that applied in many ways, whether that's contactless payments or retail shopping behaviors, things like that.
Yeah. Yes. Another thing that we do is actually we have a studio for data creation. So for example, if we need images of people or images of eyes or people doing something, we actually film this in the studio, take images in the studio. And actually one of the recently common use cases is collecting sensory data from mobile phones. So we have about more than 200 mobile devices, and people use them, and we collect the data as people use these devices. And they have to go through certain protocols or scenarios for the data to be collected. But for some reason lately, that's a common use case.
Yeah, that's cool. And we'll get into that a little bit with sensitive data, obviously, like gathering electrosphere type of stuff can be a sensitive topic, but when you've bought your own phones and distributed them, people know what they're getting into with that. And that's a pretty cool way to make a realistic scenario of something that you've created your own data set with without gathering something that's public and protected. So that's really awesome. And we'll get into that later. But so those are awesome. So let's get into the validation process on this. And we touched on this a little bit. We said if humans are given the right instructions, we can be fairly accurate on validating and telling, or just even gathering in the first place about what is good data and what is not, if the instruction set was good. I think the same can be said of automation, but there's a little bit of more obscurity when it comes to automation. What does that validation look like, especially from the automated process? I assume it could gather a bunch of irrelevant data. And I know we talked about it's a little manual, but what does that process look like? Let's say we've done a scraper and we've grabbed a bunch of images of autonomous vehicle images.
Okay, so for the validation, you have to have a pair of human eyes looking at it. We also run scripts and we have some automated process in place, but it has to be actually a human input in there, because without human input, we cannot validate that it's good, that it's ground truth. because otherwise it would be machine teaching a machine, and at some point it will not, it might work for some time, but at some point it will not be accurate. So there's always a human involved in the process.
Yeah, that's at Cloudafactory we say, be the machine or train the machine, right? We can either keep doing the annotations manually, which is fine. Over time, we understand, right? You need to include automation in those. So feed the machine. And then a part of that is human in the loop, that validation process. Not just labeling, but
Yes,
validating
absolutely.
outcomes, validating what you're putting in before you even make labels on those, that data set. So that's really good to hear you say that and validate what Cloudafactory believes in using technology to leverage those things, but always firmly believes humans will be in some sort of way, shape, or form guiding that technology. Is there a common type of task or field set you get asked to work with? I know you touched on agriculture and supermarkets, things. Is there a common one that's booming right now?
So autonomous vehicles, it's very popular right now. Retail, it's getting there. Now, another thing that I've not mentioned before is medical. We also collect medical imagery. So that goes through partners. All this data has to be anonymized, but that's another field that is growing.
Awesome. Yeah, and that's funny that you would say the medical, because our next polling question leads into our next topic, which is our sensitivity on subjects. So this poll says, is the data you work with subject to any following compliance requirements? GDPR, HIPAA, SOC 2 or other security requirements, or no compliance requirements? And I realize that it may fit into multiple of these, but what have you seen most commonly on these, Maria, happen usually when you're working with data collection?
GDPR, it's usually important. It
GDPR.
Depends on the field. It really depends.
Right, HIPAA is just a US-based type of thing, and then GDPR all across Europe. So let's see those results and see what people have typically run into. Okay.
No compliance requirements. That's interesting.
Yeah, I would say we could define that, and I'd love to have a conversation. And if you guys want to put in Q&A, what types of data sets you're using that don't deal with compliance requirements. I know when you're talking about inanimate objects, then maybe I could see that a little bit, but that'd be interesting to see the breakdown, some Q&A, and we can answer some of those questions. So moving on, we've gathered our data or created a data set, whatever we're working on in the field that may be, now let's say we're in a field that may be a bit sensitive, like our healthcare field or autonomous vehicles when you're talking about faces and plates and things like that. We can have certain restrictions or hurdles. So, medical specific, we need to be able to have a de-identifiable way to get that data out of there, or deduplicated or anonymized. So like license plates we talked about, there are certain good tools that are good at this automatically. So the data doesn't even need to touch or see human interaction, right? Until it hits the tool. We can have that process linked in, and that's a digital process. And then there's others that we talked about with humans can be trained to anonymize and to obscure or delete data if there are certain metrics or waivers signed, right? So if they're viewing that data, they need to know what compliances need to be in place before they're doing that. Oftentimes it's a lot of metadata, right? So there could be stuff inside or underneath when you're talking about DICOM images, things like that have metadata in them. Titles of people, PII, you name it, there's certain areas. Do you at KeyMaker de-identify data, or does it come to you de-identified already? How does that look like?
So both. For example, when we work with medical data, when we receive medical imagery, it's already anonymized. But what we do, we de-identify it even further. So basically, what's left, we remove all the details that are not relevant and crucial to the task. So, for example, for an image, if you don't need to know a gender or a birth date of a person, it's all removed. Everything that's not relevant is removed. Now for, let's say for retail or for autonomous vehicles, we remove license plates. If license plates are not required, we remove the faces of people in the supermarket, even though they consent, but we still remove this unless there is a specific requirement that the people need to be visible and their face should be somehow recognized. But again, let's say if we are collect this data, these people already know that that's what's happening, like consent. Now, in terms of compliances, it really varies. Some companies need to comply to the most strict regulations. Usually international companies that operate in multiple countries, they have to comply with the regulations of all the countries at the same time. So that's pretty strict. It's the privacy of the data and compliance very important. Other companies need to comply only with the local regulations, so it makes it easier for them. So what we do to comply with the regulations is, first, we don't store the data. Sometimes we even just create pointer if we collect data from instead of creating, we're actually collecting the data. Instead of saving it, we just make a pointer to this data. And the client himself can decide if they want to download it or they just use it where it is. So there is no data being downloaded, or let's say there's no data transaction. So basically no rules are being violated.
Yeah, no security violations.
Yes, exactly.
Compliancy issues, things like that.
Yes.
Yeah, that makes sense.
So when we create the data, there's no issues at all because we're actually creating the data.
That makes sense. I appreciate that insight. And I would say that we're by no means experts in the HIPAA and the GDPR realm individually, right? As companies, we have consultants. I would say to talk to lawyers, talk to different companies that handle that. Both of us have partnerships that can de-identify this data or develop algorithms that train and obscure other data, like we talked about, or it can come to us natively in a tool. Or often you can refer to tooling partners or things like that that may have HIPAA compliance or GDPR compliant personnel at those companies that we'll often bring in and use as a consultancy together as a team to ensure that we're meeting your needs and your standards. That's the best way to approach it.
Yes, that's usually the common practice. The company knows best for itself what should be done, and we just comply with the requirements of the company.
So now we talked about GDPR, but HIPAA is something that was on the poll, and I don't want to pretend again like we're experts here, but we have experienced these types of data sets or before we experienced the data sets, we've been asked these questions. Not a ton of deep level knowledge, but like we said, consult with lawyers, know where to look. Oftentimes tooling have personnel that can navigate that. It has to deal with HIPAA, in my understanding, deals with a lot of data transfer, data storage, viewing. Consent is a big one that can kind of get rid of a lot of those requirements. But if that's not in place, oftentimes, and you need to gather a lot of data set, you need to make sure those are in place. BAA agreements, so all parties need to be signing those. It can be more difficult, especially for workforce, right? As we went distributed for Cloudafactory, we have metrics in place where we can show our compliances in certain areas of this. So consult with one of us is basically what we're saying here. Come to us, talk to us. We'll tell you how we navigate and manage the data so it's protected. Not only did the tool need to be HIPAA compliant, but that workforce does. So I don't want to go in total depth on HIPAA because, like I said, we're not experts on, this is definitely HIPAA compliant. We know the topics to look at and who to bring in. But what are your high level concerns with complying with HIPAA, Maria, when you're talking about that and working with it at KeyMaker?
Well, it's really country dependent, right? HIPAA is relevant to US. Now, what happens when data comes from other countries and you use this data to train models that are later should be applied globally? So again, it's very case dependent. I'm not a lawyer, so I cannot tell exactly what happens in what case, but usually you should consult with a lawyer in this case, especially in regards to medical data, because that's pretty strict.
Yeah, and something that came to mind when you said that is asking questions, right? So making to ask the right questions to ensure you have the right answers for that. Are there any other concerns or fields or compliance standards you run into often globally?
Well, of course, there's everything to do with face recognition. It's a very controversial subject right now, but I think you covered all of them.
Perfect. Awesome. Yeah, so that being said, getting past the sensitive part of those, like just being aware that they exist and knowing you need to follow the standards, please, when you're talking about those. Talking about what if we've got the data, let's say we don't have the data. What if it doesn't exist? What if that doesn't exist? And what are our options if that data doesn't exist?
Okay, so as was mentioned before, we can actually create the data. For example, the image you're seeing right now is part of our data collection for autonomous vehicles. We just have dash cams constantly on the cars that's collecting everything, that collecting videos of the car driving around in various locations. So creating the data, actually. Filming, taking pictures, or as I mentioned before, sensory data from mobile devices. So that's option number one. Second option is synthetic data. So what I mean by synthetic data, so there are two main ways to do it. First is take existing data and use image augmentation techniques to change each image. You can flip it, you can change colors, you can crop it. It's a whole science by itself.
Yeah.
The second option is to actually create synthetic data by 3D or 2D modeling. There are also many options there. But for some reason, we did not encounter much demand for synthetic data.
Interesting.
So far. So there are pros and cons to synthetic data. Again, sometimes it works, most of the times it just doesn't fit the needs, or it's not, it cannot be applied. But again, it's a whole subject by itself.
Yeah, that's interesting. I know of one use case that we have at Cloudafactory, Hummingbird Technologies. I think synthetic data, oftentimes from my understanding, by no means do we create synthetic data at Cloudafactory, but Hummingbird Technology data scientists, because they were doing agricultural growth periods, and because maybe for some reason that season was shortened, they can introduce synthetic data from 3D, 2D modeling internally from their data scientists. That automation included can kind of lengthen and simulate the long growth period with that synthetic data. But like you said, right, going back to biases, you can have some unintended biases in that may not match.
Yes, also here, like with the biggest problem of synthetic data, it's again a machine teaching a machine.
Yep. Yeah.
So that's something we want to avoid.
Yeah, they could go rogue for sure. Yeah, that's good. And I want to remind people before we end here, this is towards the end of our conversation on the topics we had to cover. So you guys can submit questions at the bottom. I know we have some Q&A open there. We had 2 questions in there. So we'll go ahead and start answering them. I'll read it off. I've got it on my other screen here. So question 1 is, do you have any initiative regarding COVID-19 data sets? Um, so I know from our perspective, I had an answer, but I want to ask you, Maria, like, have you seen an uptick or an increase in demand for that data for COVID-19 training?
Okay, so there is a demand for that, but for some reason, for us, it was impossible to get.
Okay. So I know one use case, and hopefully our team can link it here or at the end or when we send the webinar out, but we did do a collaboration with one of our tooling partners, V7 Limited, on their tool, Darwin. And we've got a data set of lungs and determining COVID symptoms inside the lungs. So using segmentation to get the shape of the lungs, and depending on the surface area, it would tell if there's COVID, pneumonia, different things like that, which was interesting because I think we were kicking off this project initially for general health and safety concerns. And then it transitioned to, oh, now we can detect COVID. So you can find the publications below in the chat. I think our marketing team is sending that out. And then the question for you, Maria, do you have any recommendations or best practices as the portability of data sets? An example, building computer vision data sets so that they can be used for different ML services like Google Vision and Amazon Recognition.
I'm sorry, can you repeat this question again?
Yep. Do you have any recommendations or best practices as to the portability of data sets? So the example for the portability of the data sets or best practices was building computer vision data sets so they can be used for different ML services like Google Vision and Amazon Recognition. So maybe
okay. Now I understand. It's a great question. To be honest, no. For so far, we never, in KeyMaker, we never created the same data set that can be used in two different models. From our experience, it never happened so far. I'm sure there are some, but nothing that I can really give you any insights on.
Understood. So it's probably not best practices to use a generic or modular thing. Sometimes it can be what you're doing.
Yeah, so basically when we create custom dataset, it's the whole point of it is that it's custom. It fits perfectly to the needs of a certain algorithm with its own specifications. But if you take the same thing and apply it and copy paste it in different place with different algorithm, it probably will not work so well. It might, but usually it doesn't.
Makes sense. Thank you.
So yeah, there should be best practices, but I really cannot, not that I know of.
Right. Okay. Thank you. And then another question that came in is, when will we see the impacts of data quality on algorithm? I'll let you answer that.
Okay, actually that's great. And it goes back to what we discussed before for collecting data in tiers. So the moment you train your algorithm with the data, even if it's a small chunk of data, you already see the impact. And that's a very important part of actually creating a data set that's good, going back, collecting small little chunk, running it by the algorithm, getting results, and adjusting for the next data collection, creation, and labeling.
Nice. So yeah, it's a tier approach and it's dependent, right? The answer is dependent. It depends on if you met the metrics above, like we talked about, what types of data, are you having the quality, the density?
Yes.
Maybe your results will come sooner than later and the impact may occur sooner than later, but it just depends.
Yeah, it's basically, it's basically every time you train the algorithm, you basically collect the data, run training, get feedback, adjust the data.
Perfect. Iterative process. That's what we say. Like, it's good, you can give us the instructions, we'll do it. But we need you to be involved in this iterative process because we may find out things along the way we didn't know or we're uncertain of and we need to retrain. So something else, how can we correct for flaws in an already created data set? i.e. not enough variance.
So flaws, you mean not enough data?
Yeah, I assume like not enough data, or a flaw as in, hey, we've got too much biases, or hey, it's picking up on
Okay.
this object when it's supposed to be picking up on that object.
Okay, perfect. So that goes to the previous question. You see how your algorithm performs. If it doesn't perform well, then one of the reasons might be the data that's not good enough, or not enough data, or the labeling is not exactly what it should have been. So that's where validation of the training data is very important. So there actually, we'll make sure that actually the data that you're using is good and according to the requirements for this particular scenario. Also, just again, collecting some more data, or even creating a whole new different data set for this use case and seeing how it performs would be a good practice.
So
But I would say validation maybe adding a bit more.
validation.
And yeah, and of course making sure there's no bias.
Yeah, and I think we've talked about this before we wrap
Yes.
up. Like,
Yes.
if you get too much bias, you may need to restart your algorithm too, right? So you may need to start from scratch. So and figure out where those biases came from before you start over again to not introduce them. Let's see. So I appreciate everybody for coming. I don't. We could belabor this forever, like we both talked about. There's so many subsets of just even data acquisition, as it's one of the beginning steps, and that's important. We talked about what quality in, quality out, which is the same as to say junk in, junk out. So you need to be really good about this process and follow the tenets. We talked about what makes the ideal data set here. We talked about bringing or finding our own data set. What's the best option, open source or building? We talked about building might be the best option because open source isn't really as granular. Best practices for when we do build our own data set. Some of the topics that come up when sensitive data appears and how to tackle those if you're unsure. And then what if the data doesn't exist? We talked about synthetic or augmented data and kind of the surface of what those look like. So I want to thank everybody for coming here, to being a participant and listening and actively asking questions. Just remember that we will send a recording out in the next few days, and you can reach out to Keymaker or us. We both have partner pages on our pages as well to see the abundant resources that we have. And I wanted to thank you, Maria, for being here on this, as you've added a lot of valuable insights that I couldn't have. So thank you for being here.
Thank you, Anthony. It was my pleasure.
Thank you.